Kia ora Year 12 and Year 11. This is an AS question about functions from the 2016 March paper. It's a really good question with quite a lot of things that are worth going over. So the first bit is algebra, and it's kind of annoying, but it's not too hard. We're given a general quadratic, which is f of x is equal to this thing here, and it's defined when x is less than or equal to 1 over 2a. So we're going to use that bit of information in the second part of the question, where we have to find an expression for the inverse of the function and give the domain. This comes up all the time, but it's often quite badly done, so well worth going over carefully. And in part one, we have to pin down the values of a and b from 2 bits of information. So you can probably already guess we're going to have some simultaneous equations work to do in here. So I'm going to start with part one. So I want you to pause the video and try and do it as we go, but please watch fast forward till the end, because I'm going to go through the examiner's report for both of these questions. So f of negative 2 is equal to 4a squared minus b plus 8. So f of negative 2 happens when we substitute in x of negative 2 into the function. So that's equal to a squared times negative 2 squared minus a times negative 2 plus 3b. So that gives us 4a squared plus 2a plus 3b. So rearranging that gives me 0 is equal to 2a plus 4b take away 8. Okay, so obviously other ways that we could have rearranged, but that will do us for now. I'm going to do the same thing now with f of negative 3. So we know that f of negative 3 is equal to 7a squared minus b plus 14. So that must equal 9a squared plus 3a, what's the last bit? Plus 3a plus 3b. So again, what I'm doing there is I'm just substituting negative 3 into x in f of x. So cleaning this up is not quite as good. I get a quadratic, so I get 0 is equal to 2a squared plus 3a plus 4b minus 14. And now I can look back up here at this link between a and b, and I can see that the best way to go from here, I think, is to eliminate the 4b. So from star, we get 4b is equal to 8 minus 2a, which gives us 0 is equal to 2a squared plus 3a plus 8 minus 2a minus 14, which gets us a nice easy quadratic of 2a squared plus a minus 6. And we can solve that by inspection, and we get 2a times a. Now we want two numbers that are going to multiply to negative 6. You could do grouping on it, but I think most of you should be able to see that if we use 2 and 3, and we stick the 2 here and the 3 here, we're going to get a gap of 1, and we want it to be a plus a, so it's going to be the plus here and the minus here. So that's going to give me two values for a. So just make sure that you're not doing this on your calculator. You will miss all of the method marks if you are. So 2a is equal to 3, a is equal to 3 over 2, or over here, a is simply equal to negative 2. Right, now 4b is equal to negative 2a, so negative 2 times 3 over 2 plus 8, which gives me negative 3 plus 8. So 4b is equal to 5, b is equal to 5 over 4. So that's the first combination got. And now we have to do the same thing with a equals negative 2. So 4b is equal to negative 2 times negative 2 plus 8, which equals 12. So b is equal to 3. So there's our second pair of numbers. Okay, so it's probably that's probably all we need to do on that one. The next one is more interesting and also a little bit harder. But you should be used to by now the idea of the domain and the range of the function, and that when we take the inverse, those two things swap over. So when I do this next question, I'm going to start by finding the domain even before I do the expression for the inverse. Right, so let's take a look at what we've got. Well, we've got a specific case, which is going to make things easier. So f of x is equal to 1 squared times x squared. So x squared minus x minus 3. And the domain for that is x is less than or equal to 1 over 2a. So x is less than or equal to 1/2. So what we need to figure out before we do anything else is let's look at what this function looks like. Think of it graphically. Oop, turn that ink to shape feature off my OneNote. And I'm going to start by completing the square. And so when you've got a quadratic, completing the square gets you into vertex form and means that we can see what the parabola looks like easily, right? All we know so far, having it like this, is that it's some kind of up the right way parabola, and it's got a y-intercept of -3. But we need to know a bit more than that. Right, so at this stage of the year, you should be extremely confident with completing the square. If you're not, go watch the video I did on that and do lots of practice at it. It comes up all the time. So we've got x minus 1/2 squared minus 1/4 minus 3, which is x minus 1/2 squared minus 13 over 4. So that straight away gives me a whole lot of useful information about the domain and the range. We can sketch it, and then we can see why we've got the domain defined as it is. So sketching this, we've got 1/2 here, and we've got the vertex down here. So my function looks like this. Now, that whole parabola would look like this, but we only want the bit for x is less than or equal to 1/2. So that's f of x. And the reason we only want that bit is because when we go to invert it, it won't work if we have the whole thing, right? So yes, this is a diversion from this question, but this is kind of important, right? So this function is a function because it passes the vertical line test, right? So for each x value, there's only one y value. But it's not 1-to-1 because for some, in fact, for nearly all y values in the function, in the range, we have 2 x values. And that means it's not going to be invertible. So to make this function be invertible, we define it so that the domain of the function is just x less than or equal to 1/2. This is going to become the range in my inverse function. So the way that I do these questions where I'm finding an inverse is like this. We've got our function, and we've got the domain, and we've got the range. So the range here is that y is greater than or equal to -13 over 4. Now we can see that from in here, right? So I've rewritten the function like this. This bit here will always be positive or 0, and this will just be take away 13 over 4. And you can see graphically that my range is values above -13 over 4. So when we do the inverse, this is going to become my domain, right? So x is going to be greater than or equal to -13 over 4. And my range is going to become this. And you'll see all of this falling out of the algebra as we go. Okay, so the examiner's report commented that very few students had got the whole of this question right. And you'll see the bit where we've got to be careful coming up. So we've now found the function in completing the square form. So finding the inverse is quite easy. We just switch over the x and the y. So in here, we've got y equals this. So for the inverse, we're going to rearrange. We have x is equal to y minus 1/2 squared minus 13 over 4. That gives me x plus 13 over 4 is equal to y minus 1/2 squared. Now we've got to take a square root on both sides. But what we have to think about is which one we want to end up with. So let's start by just putting down both of them. And that gives me my final equation for the inverse of y equals 1/2. And then it's going to be either the positive or the negative branch. So the first thing to notice in here is that we've got clearly a domain where x has to be greater than or equal to -13 over 4. Otherwise, we won't have a positive number or a 0 or positive number under my square root sign. So it makes sense that my domain of my new function is that. Now let's think about whether we want the top branch or the bottom branch. Well, we know that my range is going to be less than or equal to 1/2, and that's only going to happen if I have the takeaway branch. So here, my inverse is going to be 1/2 minus root x plus 13 over 4. Okay, because we want to end up with the range of the inverse being the domain of the original function. And I've got some GeoGebra to show you what that all looks like. Wrong one, here we are. Okay, so this is got 3 lines on it. The red line is the y equals x line that we're reflecting in. The blue line, which sadly has been a bit chopped off, is my original f of x. I don't think I can, or maybe I can, yeah, I can write on this. So this is f of x here, and the inverse function is the reflection of that blue one in the red line. So this is my inverse function, and you can see that the point of invariance is this one here, so that won't change. But for example, this point here will move to this point here. Right, so we want the bottom half of that function of y equals 1/2 plus or minus root that. So you can imagine that the top half goes around like that, right? But that doesn't fit with what I started with, which was the blue part on the left-hand side of the parabola. Okay, so that's a very long way of saying, have we answered the question? Yes, we have, right? So we've found an expression for the inverse, and that's it here. Right? And we've also found that the domain is x greater than or equal to negative 13 over 4. Lastly, I want to show you what the examiner report said on this. So it said that weaker candidates couldn't do this question at all, but most students figured out that they needed to substitute -2 and -3 and then to solve, and they made lots of sign errors. It also says if you got your answers to these straight out of a calculator, then you chucked away marks. And then it said a number of students did not realize the need to complete the square first in order to find the inverse function, right? If you don't do that, you're not going to get very far. And then it said only the very best candidates realized that because of the given domain, we wanted the negative rather than the positive option. Okay, so there we go there. That's the final exam answer from them. Thanks for watching. I'm going to try and do some of the geometry and trig questions over the next few days. If you've got any requests for AS questions you want done, please shoot me an email. And this is my email address here. And also you get a prize if you've watched till the end. Okay, see you later.